standard practice of many microbiology labs is determining the number of viable cells in a sample. A common method for this is the drop colony forming unit, or CFU, assay. However, due to the time and resources required, this method is often a rate-limiting step for high-throughput viability measurements. Here, we introduce the geometric viability assay, also known as GVA. GVA reduces the time and materials for CFU measurements by over tenfold, while maintaining a simple protocol. To perform GVA, you'll first prepare your agros. GVA uses melted agar in cell culture medium at a final concentration of 0.5% after mixing with the sample. A microwave on low power may be used. After melting the agros, leave it in a 50° centigrade heat bath while preparing your experimental samples and gathering supplies for GVA. Along with cells for each condition, you will need a box of autoclaved pipette tips, a small ice bath, a 12-channel pipette, and an empty tip box with a small amount of water. Once you are ready to perform GVA, you will first add your optional colony stain, in this case TTC, to the agros. The purpose of this protocol is to mix the cells with the agros and suspend them within the pipette tips to be grown and counted. For each row using the 12-channel pipetter, aspirate the agros and dispense it into the plate with your conditions. Pipette and mix at least 2 times and then pull up the agros back into the pipette tips. The volume pulled up should be less than the total volume of media in each well. Briefly dip the pipette tips in ice for 5 to 10 seconds to solidify the agros in the tip. Eject the pipette tips into the empty tip box. Repeat the same protocol for each row for as many rows and plates that you have. This protocol is conducive to high-throughput experiments with large number of conditions. Leave the pipette tip box on the bench for about 30 minutes to ensure the agros is solidified before placing it in the incubator. After the proper incubation time, you will be able to see the stained cells that have grown in the tips, and your cells will be ready to image and quantify. Through this protocol, GVA enables accurate viability measurements across 6 orders of magnitude and greatly reduces time to allow for high-throughput viability screens that continue to accelerate the pace of biological research.